Well, first let's go ahead and just try to find the minimum of this expression using derivatives. Let's set the first derivative equal to 0 and look for a critical value. So we'll set the first derivative equal to 0. So the derivative of each term, and then we'll do the power rule, -2 times this to the -2nd, which puts that in the denominator to the second power. Chain rule, so times the derivative of the inside, which is cosine minus sine. All right, let's set that equal to 0. See if we can solve that. Looks kind of complicated until we recognize, wait, we have two common factors, cosine of x minus sine of x, cosine of x minus sine of x. So we can divide both sides by that difference. And then we can multiply both sides by the denominator. And then we can take the square root of this squared component, giving us the positive or negative square root of 2. And then why don't we go ahead and add 1 to both sides. And so we know that critical values occur when the first derivative is 0. And the first derivative is equal to 0 when sine of x plus cosine of x is 1 plus or minus root 2. So if there's going to be maximums and minimums of this expression, then they will occur either at endpoints, but there are no endpoints because this is defined for all real numbers. So if there's a maximum or minimum, it will have to occur at a critical value, which is when it's either non-differentiable, but it's a differentiable everywhere, or when the first derivative is 0. So we'll have a minimum or maximum when this is true, which means when sine of x plus cosine of x is 1 plus or minus root 2. All right, let's use that then. So if sine of x plus cosine of x was 1 plus root 2, then this expression would be 1 plus root 2 plus 2 over 1 plus root 2 minus 1. And if sine of x plus cosine of x was 1 minus root 2, then this value would be here. So we use our critical values, which is where there's going to be a maximum or minimum. We substitute it into the expression, and the minimum of this value is going to be whichever one of these is smaller. All right, so this expression yielded this. This expression uses the absolute value of this. Clearly, the absolute value of this will be a smaller value than this. So this is our answer, which is the minimum of the original expression. And since 1 minus 2 root 2 will be negative, the absolute value will take the opposite of it. So I would rewrite this as positive 2 root 2 minus 1. Final answer. Now let's just go ahead and see if this comports with the graph. All right. Well, first of all, our minimum we believe is about 1.828. And if we graph this, seems like we nailed it. The minimum is about 1.828.